All right. Hey, everybody. Welcome to class I. We're going to talk about trigonometric functions. I will share my screen. Cool. So, trig functions. We're going to define them. It's a definition. And we're going to talk about how to evaluate them. I should specifically say, we're going to talk about them in the context of right triangles. So trig functions in terms of right triangles. There are other ways of defining trig functions, which we'll talk about later. For now, we're talking about in terms of right triangles. So let's say we have a couple right triangles. So I'm going to draw them kind of in the classic orientation, and then it may be a different way. So let's say we have this right triangle. And we also have this right triangle over here. I'm going to draw it sort of like this. Yeah. So I can also, I'm gonna draw one more. Actually, yeah. Each of these right triangles, they got a right angle. So right there, right there, right there. And we're going to label one of the acute angles in each of these right triangles. Acute just means an angle less than 90 degrees, and positive. So not the right angle, one of the other two angles. So I'm going to say, let's call this angle theta here. Let's call theta here. Let's call it theta here. Okay. So the first thing to do is after we have identified the angle, we're going to label the sides. The longest side, opposite the 90-degree angle, is always the hypotenuse. Only right triangles have hypotenuses. So this side over here is the hypotenuse. This side over here is the hypotenuse. And then the way I think of it is the side that is opposite the angle is literally called the opposite. So looking over that way, that's the opposite. Or from here, that's the opposite. From here, that's the opposite. And then finally, the remaining side is the adjacent. You can also think of the angle is always going to, the acute angle, not the 90-degree angle, is always going to be between the hypotenuse and another side. The other side that's next to is called the adjacent side. So this side here is the adjacent, which I should use the capital A for. Oh, well, it doesn't really matter. Over here, we have the adjacent. And over here, we have the adjacent. Adjacent. Cool. So now we're going to define the 6 trig functions. So define the 6 trigonometric functions. I guess I could write out trigonometric functions. We'll start with sine. So sine of theta is equal to the opposite side divided by the hypotenuse side. So we are this opposite over hypotenuse. Cosine of theta is defined to be as adjacent divided by hypotenuse. And tangent of theta, you can think of as either sine divided by cosine, but typically in the right triangle situation, we define it as the opposite divided by the adjacent. But you will notice that if you divided sine by cosine, the hypotenuses would cancel and you would get opposite divided by adjacent. So those are like the 3 main trig functions, the primary trig functions, and the other 3 are called the reciprocal trig functions. So we have cosecant of theta, which is the reciprocal of sine. It's going to be the hypotenuse divided by the opposite. We have secant of theta. I'm going to use parentheses here. You don't have to use parentheses, but I like parentheses. Which is going to be the reciprocal of cosine, which is the hypotenuse divided by the adjacent. And finally, we have cotangent of theta, which is going to be the adjacent divided by the opposite. You'll notice that each of these over here is the reciprocal of each of those over there, and vice versa. Each of these over here is the reciprocal of those. When things are reciprocal, they are reciprocal pairs. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. I really, really, really encourage you to say these words fully. So don't say sin, cos, and tan. Say sine, cosine, and tangent. And this one's kind of hard. You say cosecant. Sec, no, we say secant. And cot, we say cotangent. So those are the 6 trig functions. And let's talk about how to evaluate the trig functions of an angle and a triangle. I will say, there's one other thing I should say here, which is important. Not important, but useful. So one way people remember these 3 trig functions and what they're equal to in terms of the right triangle is the mnemonic device SOHCAHTOA. I like writing it either like this, so ka toa. I do like emphasizing the A sound there in the ka, because I've heard students say SOHCAHTOA and write it as an O instead of an A. Yeah, cool. So make sure you say SOHCAHTOA. I've also seen people write it like this, as whoops, not starting with the C. Goodness, let's just scratch that out there. Writing it as SOHCAHTOA. To remind themselves that sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, tangent is opposite of adjacent. Or you can do it like this: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Whatever works best for you. I have not found a nice mnemonic device for the other 3. The easiest way to remember the other 3 is to remember what the reciprocals of. So you could like for example, if you wanted to, you could try cho, sha, cow. That doesn't seem very good, right? Cho, sha, cow. No, I don't love it. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. I don't recommend that. What I recommend is remembering that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So let's look at some examples. Let's say we were given this triangle. Example 1. Good old, we'll do a classic 3, 4, 5 triangle. And we wanted to find the 6 trigonometric functions of this given angle theta here. Notice we're not actually being told what the angle theta is, and we often won't be when we're just making up sides of triangles. So I want to find all 6 trig functions. Find all 6 trig functions of theta. In case you're curious, theta is spelled Theta. It's pronounced, as I've said it, theta. It's kind of the standard angle people use for things, but I'll use a couple other Greek letters as well, just to kind of mix it up. So in this case, sine of theta is opposite over hypotenuse is 3/5. Cosine of theta is adjacent over hypotenuse, which is 4/5. Tangent of theta, and you don't need parentheses here, but I like having them to kind of emphasize the fact that we're putting something into the trigonometric function. Tangent of theta is opposite over adjacent, which is 3/4. And there's a reason why I write them this way, so that the reciprocals go next to the things the reciprocals of. So cosecant of theta, which is the reciprocal sine of theta, is going to be 5/3. Secant of theta, which is the reciprocal of cosine, is going to be 5/4. And then cotangent of theta, being the reciprocal of tangent of theta, is going to be 4/3. There's not a whole lot else to it other than making sure we recognize things correctly. So let's look at another example. Let's say I had a similar looking triangle, although not the same triangle. And let's say I'm going to have the sides be this time, I don't know. Sure, we'll go with some not so nice numbers. Let's say we have 4 square root of, 33, and then 7. All I'm doing there is I'm checking internally to make sure that 4 squared plus the square root of 33 squared equals 7 squared, and it does. 4 squared plus the square root of 33 squared is 16 plus 33, which is 49, which is 7 squared. So the sides of a right triangle do make sense. But now we're going to call this angle, and let's give it a different name. Let's call it alpha. So now I want to find the 6 trigonometric functions of alpha. When we do this, we have to make sure that we still think of the opposite and the adjacent things as the correct things. So for alpha, 4 is the opposite, and root 33 is the length of the adjacent side. Whereas for theta, this was the adjacent and that was the opposite. So it depends on which angle we're talking about. So same deal, it gets a little repetitive. Sine of alpha is going to be opposite over hypotenuse. cosine of alpha is going to be adjacent over hypotenuse. And tangent of alpha is going to be opposite over adjacent. Typically, when we have a radical in the denominator, we rationalize by multiplying the top and bottom by that same radical. So we multiply by root 33 over root 33. We end up getting 4 times root 33 in top. And root 33 times root 33 is just 33. All right, same deal for the rest of these here. Cosecant of alpha is the reciprocal sine of alpha, so it's 7 divided by 4. Secant of alpha, which is the reciprocal of cosine of alpha, is going to be 7 over root 33. And we're going to rationalize. We're going to multiply by root 33 over root 33 to get 7 times root 33 over 33. And finally, cotangent of alpha is the reciprocal of tangent. Now, here's where we want to be smart about how much work we're going to try and do. Instead of doing the reciprocal of this, I don't want to write 33 over 4 root 33. I'm going to look at the original unsimplified answer and be like, oh, it's the reciprocal of that. Tangent's going to be, sorry, cotangent of alpha is going to be root 33 over 4. Alternatively, you could just go back to the definition and say, oh, cotangent is adjacent over opposite. So cotangent of alpha is the adjacent side over the opposite side, which is root 33 over 4. But I think it's silly to like do the reciprocal of this and then rationalize it again and cancel stuff out. So try to do your work efficiently. Let's look at a couple more examples. There's really not much more to this right triangle stuff other than identifying the side. So let's say we were given this. So given this triangle, let's call this side, let's say this is 6 and this is 5. I want to find, let's say we have, sure, this angle here, let's call it beta. Looks like a B, except like this part's a little bit longer, a capital B, and this part's a little bit longer. So I want to find the 6 trig functions of beta. Great. Well, to be able to do any of that, I'm sorry, I should label my right angle here. It should be obvious, but also it's good to label what you mean. So to find the 6 trig functions of beta, I need to find the length of the third side of this triangle. So let's call it x. You could also call it opposite if you wanted to, but whatever name you want to give it's totally fine. And then Pythagorean theorem says 5 squared plus x squared equals 6 squared. So 25 plus x squared equals 36. X squared equals 36 minus 25 is 11. So x is going to be the square root of 11. And it is positive because we're talking about triangles, so the lengths are positive. So that's going to be the square root of 11. And now I can go ahead and find the 6 trigonometric functions of beta. So sine of beta is opposite over hypotenuse. So root 11 over 6. Cosine of beta is adjacent over hypotenuse. So 5 over 6. And tangent of beta is opposite over adjacent, which is root 11 over 5. And then cosecant of beta is the reciprocal of sine of beta. It's going to be 6 over root 11. I never think to myself that cosecant is hypotenuse over opposite. Yeah, I could, but really I'm always thinking of it as the reciprocal of sine. Now, I know sine is the opposite of hypotenuse, so cosecant is just the reciprocal of whatever that is. But I really, really, really never say hypotenuse over opposite. It just doesn't happen. So, and then I should rationalize this. I'm going to multiply it by root 11 over root 11 and get 6 times the square root of 11 over 11. And then same deal for secant. Secant of beta is the reciprocal of cosine of beta, which will be hypotenuse over adjacent. That one we don't do anything with. You could write that as a decimal if you preferred to, but I would leave it as a fraction. Finally, cotangent of beta is going to be the reciprocal of tangent, so it'll be 5 over root 11, which is adjacent over opposite. And then we're going to rationalize that by multiplying by root 11 over root 11. You don't have to show this step of multiplying by root of whatever's on the bottom over root of whatever's on the bottom, but you do need to do it. But you could totally just say, you could be like 5 over root 11 is equal to 5 times root 11 over 11 if you don't want to write out that you're multiplying by root 11 over root 11. Let's do one more, and then we will call it a day. So let's see here. Let's say our example is, let's draw one that's kind of funkily drawn here. Sure. Let's say we have, there's your right angle, and let's say we're given these sides here. I'm just going to make something up. Let's say this is 7 and this is less than 7, so 5. All right, and we're trying to find the 6 trig functions of theta. We'll call this one theta. We'll do a little bit more with this one, but this will be the starting place. So first we're going to do that. So, first we have to find the missing side. So let's call that x or y or opposite, or I'm not opposite, hypotenuse, whatever you want to call it. I like x. X is kind of the standard choice. So here, different than last time, here the missing side is the hypotenuse side. So that's the one that goes by itself. So the equation we're going to be solving is 7 squared plus 5 squared equals x squared. So 49 plus 25 equals x squared. 74 equals x squared. X equals the square root of 74. Cool. So that's what's going to go right there. That's our hypotenuse length. Now, sine of theta, well, there's my angle. There's the opposite side. There's the hypotenuse side. It's going to be 5 over the square root of 74. And cosine of theta is going to be the adjacent side over the hypotenuse side. So it's going to be oops, I forgot to rationalize. Do that in a second here. And finally, tangent of theta is going to be the opposite over the adjacent. So 5 divided by 7. I'm going to wait to rationalize these for just a second, but I will leave myself room to rationalize them. So cosecant of theta is always the reciprocal of sine, and just it's literally defined to be. And it's going to be the reciprocal. So it's going to be root 74 over 5. And secant of theta is going to be the reciprocal of that. So it's going to be root 74 over 7. And finally, cotangent of theta is going to be the reciprocal of that, which is going to be 7 over 5. And now let's go ahead and rationalize these and multiply by, I should say rationalize the denominators of these. Root 74 over root 74, which is going to give me 5 root 74 over 74. Sorry, that's a little bit small. And similarly here, we multiply by root 74 over root 74. Wow, can I write 7s? Yes. Sorry, it looks a little bit messy there, I know. It's going to be 7 times root 74 over 74. Let's add on to this question by now filling in, let's say that this angle over here is alpha. These two angles are complementary, meaning they add up to 90 degrees. And there's something kind of special about the trig functions of complementary angles. The co-functions, sine and cosine, tangent and cotangent, secant and cosecant, that's why they're kind of named that way. The co-functions will actually interchange values, which is kind of cool. Let's check it out. So yeah, so let's do the 6 trig functions of alpha now. So now sine of alpha is going to be the opposite over the hypotenuse, which is going to be 7 over root 74. And since I already rationalized 7 over root 74 here, let's just write what it's equal to. It's going to be 7 root 74 over 74. And cosine of alpha is equal to the adjacent over the hypotenuse, which is going to be 5 over the square root of 74. Which we know 5 root over root 74 is equal to 5 root 74 over 74. And notably, the sine and the cosine values have interchanged from what they were for theta. So sine of theta and cosine of theta had 2 different values, and then sine of alpha and cosine of alpha had switched values. Similarly, if we look at tangent over here, tangent of alpha is opposite over adjacent, which is 7 over 5. And cotangent of alpha is, of course, going to be 5 over 7. So those also switch. And then finally, cosecant of alpha is going to be the reciprocal of sine of alpha, which will be root 74 over 7. And secant of alpha will be the reciprocal of cosine, which will be root 74 over 5. And we see that cosecant and secant of theta, those two values interchange to get cosecant and secant of alpha. And that's always true for angles that are complementary, that each pair of co-functions, the values will interchange. So whatever sine and cosine are here, you'll flip them and say sine here will be cosine here, and cosine here will be sine there. And the same is true for tangent and cotangent, and for secant and cosecant. Kind of neat. It's not too, it's kind of obvious after you've done it for a while that you're like, oh yeah, I'm just getting the same side of the triangle. I'm just kind of rewriting the ratios here. So that's it for defining trig functions in terms of a right triangle. Let me just reiterate one more time because it is important. Here's a right triangle. I'm going to draw it real big. Here's my right angle. Here's the angle I'm looking at. So let's call it theta. Here is my adjacent side. I'll abbreviate. Here's my opposite side. Here's my hypotenuse side. Sine of theta is the opposite over hypotenuse. Cosine of theta is the adjacent over the hypotenuse. Tangent of theta is the opposite over the adjacent. Cosecant of theta is the hypotenuse over the opposite, or as I think of it, the reciprocal of sine of theta. Secant of theta is the hypotenuse over the adjacent, or as I think of it, the reciprocal of cosine. And cotangent of theta is the adjacent over the opposite, or as I think of it, the reciprocal of tangent. Definitely want to memorize these 6 trig functions. And what I really mean by that is you want to memorize these 3, and then these 3 are the reciprocals of those 3, which is why I always write them in this order: sine, cosine, tangent, cosecant, secant, cotangent. All right, that's all I got. Have a nice day. See you tomorrow. Or whenever you watch this. See you today, whatever. Watch it tonight, though.